Hi, this is Barrett Givens. In this video, we're going to practice finding interiors of sets. And we're going to do this in the standard topology on R. So remember that the interior of a set U, is the largest open set contained in U. Okay, so let's find the interior of each one of these sets. Okay, capital A is the open interval 0 to 1. Well, in this case, in the standard topology, open intervals are open sets in the standard topology. And so this is an open set already. And so if you start with an open set, then the interior is just the set itself. The largest set you can get is just to take all of it. And so here the interior of A is 0, 1. And that's because A is already open. So its interior equals itself. Okay. The next one, B, is the set closed at 0, open at 2, that interval, along with the point at 3. So let me draw a number line. 0, open at 2, and then a dot at 3, and it's everything in this region. All right, so we want an open set that's contained in B. So we want to think about kind of how big, the open sets have to be made out of open intervals. So how big of open intervals can I squeeze inside of B? I want to make an open interval as large as possible inside of B. Well, at the one end, I can take my open interval right over to the point 2, right? And at the other end, I can get really close to 0. Can I include 0? Would B include 0? Or sorry, would this open interval that I'm trying to draw, could it possibly include 0? Well, as soon as I include the point 0, then B is not a neighborhood of 0. And so as soon as 0 is included, then the set that I'm making won't be open anymore. Okay, so the biggest open interval I can get on the left-hand side of this is just to go from 0 to 2. Now, what about the 3? Can I squeeze an open interval inside that point? No, I can't. And so the interior of B is just the open interval from 0 to 2. Okay. What about C? All rational numbers. So you want to just imagine it's like you just have a ton of dots at every rational point on the real line. So it's a very scattered sort of set. So can I get an interval inside of the rationals? If I take an interval, is any interval AB a subset of the rationals? If I take an interval of points A comma B, and I think about all of the numbers between A and B, could all of those points be rational? No, because we know that on the number line between any 2 points, there's some rationals, but there's also some irrationals, right? So between any 2 points on the number line, there's some rationals and some irrationals. And so the answer here is no. So I cannot find any interval which is contained inside of the rationals. And so that means that the interior of the rationals, there is no interior. The interior is the empty set. It's kind of weird. So the interior of the rationals is the empty set because I can't find any interval that's contained inside of the rationals because every interval has some irrationals. All right, and then the last one is the set of all D, such that D looks like 1 over n, where n is a natural number. Okay, another way to write D would be, I could sort of list them out. It's 1, 1/2, 1/3, 1/4, ... Okay. So can I find any interval which is contained inside of D? No, the points of D actually look like the point 3 on the problem above. The points of D look like the point 3 on the problem above. They're sort of away from each other. So there's no place where I can there's no stretch where I can squeeze in an integral. It's just individual points. And so the interior of D is also the empty set. Okay. All right. Thank you for listening.